We're going to start with our keynote today. And that keynote is going to be by a longtime friend of mine, Gwen Shapira. We've worked together. Gwen has a storied history in the data space, in the Kafka community, and she is now co-founder of a company called Nile that is doing some extremely interesting things in the software as a service space. And I mean that, and there is a lot to say there, and it bears directly on our work here. I think this is an incredibly important message. I don't say that just to hype the crowd up before the keynote. I really think this is an important message for us to take in. So I'd like to welcome to the stage Gwen Shapira.
Hey everyone. So excited to be here with you this morning. It is only 9 a.m. and I can feel the energy in the hallway and in the room. This is an exciting place to be. So, last year, when my co-founder and I started Nile, our mission was to help everyone build world-class software as a service. So naturally, you go around the web, you look at a lot of software as a service, you talk to a lot of people, you discuss what works, what doesn't, and you learn a lot. And one of the things we learned is around how core real-time, and especially real-time analytics, is to modern software as a service. So I'm really excited to be here today and share everything I learned and discovered with you. So I am a product manager at heart, and when I'm looking at new and exciting cutting-edge technology, the first thing I ask myself is, who is going to use it? Who needs it? What are they going to need it for? And only after I have answers to those questions, I go back and say, what is the architecture that is going to enable these people to do the things they need to achieve with this new technology? So I'm going to take you, all of you here, on this journey. And we'll start with who are the people who really need real-time analytics, because a lot of real-time analytic projects go wrong before they even started because you're targeting the wrong people. So when we're looking at real-time capabilities, a lot of people mix them up and don't quite even know what it is, the things that they need when they ask for it. So let's start with that. I think the most important capability is that the data has to be fresh. It has to be millisecond old, maybe a minute old. It cannot be hours and days old data. A lot of people mix up fresh data with a responsive UI. If you click, do I get data? This is not exactly a solved problem, but a lot more table stakes. Everyone has you click and you get data, but a lot of time the data is a day old, hours old. So don't mix them up. You need to be fresh. You need to be responsive. Now you show data, but what can you do with this data? Can you ask questions? Can you slice, dice? Can you drill down here? Can you aggregate by that? If you cannot, you got some static data, not as good as data that you can slice and dice. And of course, again, almost table stakes. It should go without saying, the data actually have to be correct. It's especially true when it is customer-facing and people use this data to make decisions. You definitely don't want people to use the wrong data to make decisions. Now, this is probably the most important, maybe second most important slide in this presentation. This is where a lot of real-time projects go wrong in the beginning. Your internal business stakeholders will tell you that they need real-time data. They don't need real-time data. They want real-time data. There is a huge difference. They can do their job perfectly well with hours, days, and sometimes even weeks old data. This is because business strategy decisions rarely change every 20 milliseconds, no matter what they think. People take long time to make those calls, and there is the entire internal trust structure that makes it easy to take time making decisions. So it's very tempting to do it internally, and the reason is that, hey, you have this cool new technology, you have Pinot, and you want to show off how you can build cool things with it. But it's your first project. You never used Pinot before. Are you going to actually go production with it? This is a bit scary. So it's very tempting to find an internal project to do it. But because they don't need the projects to be successful, they're not going to give you the correct resources and the correct support to make it successful. They will not have the patience to make it successful because they have so many other wants and needs. You will not get the... You are setting yourself up to failure by addressing an audience that can very well live without the thing that you're giving them. So I really encourage you, find the people who need real-time analytics, not the people for whom it is nice to have. And the people who need real-time analytics are your customers. And as we'll see, if you're building modern software as a service, which a lot of people here are, I know because I talked to a bunch of you, your customers very much want to collaborate with each other. Collaboration has to be real-time, right? It's very tactile. They want to react fast to things that you show them. They have the ability to react fast. They're in your website right now for a reason, to do their job, and they want to have a very interactive experience. And maybe most important, they want to trust you. And accurate, timely data builds trust. And I'm going to go and make the case for it in a second. I want to highlight how important it is that trust and data go hand to hand. And it goes hand to hand decades ago. This is not a new thing with this new technology. If you want your customers to trust you, you have to show them that you're giving them trustworthy information when they need it. If they look at your audit logs, if you look who changed, something changed, who changed it? You need to be able to say exactly who changed it. If you say, hey, your bill is this much, they will ask why. You need to show the data to support it. All those things are extremely important. Trust in the software as a service world is hard. You're asking people to trust you with their data, with their career, with their security. You have to earn it. And real-time data is an amazing way to earn your customer trust. So, modern software as a service. I keep saying this word. Does it actually mean anything? I think it does. And in order to explain what it means, I'm going to go all the way back to the least modern software as a service you can imagine. So let me take you back to the 1960s, where all we had is timeshare computers. Arguably, timeshare computers were the first software as a service because we did not have desktops. It's not we. I was not really around to compute in the 1960s. But people did not have desktops. They had to go to services to give them software. Fast forward all the way to 1996. What happened in this time frame? First of all, Moore's law happened. Your desktop got faster and faster and faster and faster every 18 months, again and again and again. This is a lot of improvement in several decades. The other thing that happened was that networks got faster and better. They did not get faster and better at the same rate. The company network, the LANs got way better, but broadband required government investment, which absolutely does not work at the same rate as Intel. So you get to 1996, you have some networks, you have very strong personal computers. This is when the first generation of SaaS appeared. It was called application server providers. And two things interesting about them. First of all, they had this vision, which is very close to the visions that a lot of us have. Software will run elsewhere, someone else will manage it, but it will feel like it's running in your computer, which is kind of the core vision of SaaS. It's run somewhere else, it feels as if it's on your computer. The second thing you need to know about those companies is that every single one of them has failed. Why did every single one of them fail? The technology was not there. You cannot build, it doesn't matter how good and how accurate your vision is. If the technology is not there to build it, you're going to fail. The network was too slow. There were no clouds, so you couldn't really scale back and forth. The data centers were not quite up to the task. The databases were not exactly what they are today. So each and every one of them failed for being unable to deliver on their vision, disappointing their customers. Again, going back, you need your customers to trust you. Only 3 years later, we are now 1999. Now, a lot more homes have broadband. Internet is getting faster. And now you're seeing the first SaaS companies that are actually successful and enduring. Salesforce, how many of you could even know that they were founded in 1999? I was shocked. They feel like a very modern company if you think about it. So this is the first time where the technology and the desire were feasible. fast forward a bit more. AWS was founded on 2006. GitHub, now everyone suddenly have this tech capability to ship really strong software as a service, the experience that people actually need. And you can see the entire field ramping up like crazy from this point on. And at 2010 is where the first companies that I would categorize as modern SaaS. They're interactive, they're real-time, they're data-driven, they're collaborative. This is when they showed up. And in 2015, 2017, it started arriving to the data space as well with the infrastructure as a service providers. This is fast tour of the history of SaaS as I see it. An important thing is that in 1999, you can say SaaS is running something on someone else's computer. Today, you cannot do that. This is not the user expectation. Yes, it needs to be as responsive as if it's on my computer, but every single successful SaaS company today is doing things that you really couldn't do in your computer. They process more data. They allow more interactivity. You couldn't go and install GitHub on your machine and have it remain GitHub because it became a community. It's about sharing. So really important to think, because I'm in the cloud, because we're in 2023, I can do more, and my customers really expect more. The demand is different. So some of the things are table stake. You have to be fast. You have to feel like you're on your own computer. And security and compliance are table stakes, because this is the trust that we're talking about. One of the maddening things, if you're a SaaS provider, is that your customers say, well, do I have to give you data? And I'm like, well, yeah, this is how we work. I am running, let's say, an expense report. So of course, your customers your salespeople will file expense reports on my platform. I will have some data that actually belongs to you. I will know some stuff about your salespeople. A lot of people are now uncomfortable with it. And you can kind of point them and say, well, but you put data in S3. But people will look at you like you're crazy. Well, S3 is Amazon, who are you? And you have to build this trust and this reputation. And again, data is an amazing way to do this. So the two special capabilities that modern SaaS have that are beyond table stakes, I think, are real-time collaboration and data-driven experience. So I'm going to give examples for those because I think show is better than tell. The thing with real-time collaboration is that we went before just running the app, and beyond just having a multi-tenant app that can be a lot cheaper because of economy of scale, and we got all the way to enable real-time collaboration, which is much harder to do when it's just something running, an app running on my machine. And this is an example from IPython as a service. There is a bunch of those. And the nice thing I want to point out, I didn't check if I have laser. The thing I want you to notice is that it's data-driven, and what the service enables is real-time exploration of data and collaboration. People can leave comments on the explorations that other people did, which is a great way if you ever run an incident or if you ever were in discussion. This is what you want. And again, one of those things that is much more effective cost-wise and time-wise to buy it from someone who did it as a service than for you to try and develop it in-house for people who may want it but may not actually need it. Getting it off the shelf for something you want but does not need is way better. And of course, if this is your business, it's a really cool opportunity. Now, data-driven experience is a lot of things, so I'll show a lot of examples. A lot of people use data to personalize the experience, show me something that other people will not because they know something about me. They have the data. A lot of it is about in-app metrics that help me make decisions in the app and navigate the app because I have some relevant data. Usage-based billing is a very big one, requires a lot of data, and customers want to nitpick their usage-based bill in many different ways. And the last one is data-driven features. Features that maybe don't show you the data, but would not exist without massive data behind them. People you may know in LinkedIn is an example. So let's look at a few. GitHub. I don't know if you ever, I'm sure if you're all engineers, you've all seen GitHub. I'm not sure if you ever noticed how almost every pixel in this page is driven by massive amounts of data. the statistics about me and who I follow, all my commits, all the repositories. If I start clicking on tabs, if I drill into a repository, how many people view this repository, forked it, downloaded it, how many commits, top committers, it is all. GitHub is actually a large real-time data analytics product that sometimes, occasionally behind the scenes, can also do some version control. Confluent. This is my favorite, partially because I participated in building it. And this is the cluster capacity planner. And what we want people to do there is to play with the slider and see what would happen if my cluster was bigger, what would happen if my cluster was smaller. Because they need to decide how much cluster to buy, and they need to decide how much to pay us. And in order for them to make the decision, we have to show them all the relevant data for making this decision. They have to see it in a way that they can use. So you can note that we have things in red where we think it's dangerous. And we let them explore it. If you want to see historical data, do you want to see something else? We give them an interactive experience as well. Note that all of this absolutely have to be in real time. You cannot play with the slider and wait 3 minutes for stuff to show up. Also note that the cluster load metric, especially, it's true for everything, but especially the cluster load metric, it has to match their experience right now. If they go to this cluster and they notice it is slow, and I'm showing them that there's absolutely no load, they will stop trusting me, right? This is all about trust. If I show them old data, bad data, misguiding data, they will stop trusting me. Or worse, maybe they still give me the benefit of doubt, but if they make a decision based on all data, they say, oh, my cluster is not loaded, it's fine, when in fact it is at 90% CPU, oops, they may shrink the cluster, have a downtime, it's all my fault. So it's extremely important to have timely data, data that they can trust, data that they can play around with. And those metrics, a lot of people told us, those were more important than actually being able to resize the cluster, which is actually technologically, it's much harder to resize your cluster. So it's always the thing that the user experience is what wins over cool technological capabilities. The other thing is that it's billing related, right? We have usage-based billing. We show you the bill. If we are charging you for certain capacity and have not delivered it, again, the metrics here do not match what you actually expect in reality, you will stop trusting us, you will start arguing over every bill. Nobody wants that. So everything has to tie together, everything has to match, and really only real-time analytics in your product can really deliver this kind of experience. Datadog. It almost feels funny to put Datadog as an example, because again, it's one of those apps that the entire application is exploration of real-time data, at least for some definitions of real-time. I think they do have like this 5-minute aggregate and delay, but very real-time, very interactive. The two things I want to highlight is that they have real-time analytics even for their billing. Datadog has famously complex pricing. It is extremely hard to know in advance how much you're going to pay at the end of the month. But they gave you the experience to look how much did I pay so far this month, what am I paying for, what are the metrics you're using to charge me, and you can slice and dice it, and you can project it in ways that will make you a lot more comfortable. They could not get away with this complex pricing model if they didn't have a really good experience with real-time analytics to back it up. And again, real-time is so important here, because if I spin up 3 new machines, and I go to my bill, and I see, oh, it's actually normal, and I sleep well till the end of the month, and then I get the bill, and like, oh my God, the bill just tripled, I will be an extremely unhappy customer. And there are some competitors that do it. You don't want to be a company that betrays your customer trust in this way. And the last example from a completely different field. I don't know if you guys went to any bars around here, but if you have, there's a good chance that you've seen an electronic beer menu. And the technology behind it is extremely cool because it is based on real-time data. If you'll see, in the bottom of the beer list, they give you in real time what beer was ordered at what point in time in this venue. So if you're wondering, what are other people drinking? What is really good? What are the locals into? You can just look and see it's essentially what is trending. It's like the Twitter trends only for beer. Extremely cool, very real time. The part behind it is that the venue owner, when they think what beers should I order to have on tap next month, they have access to the aggregated data of all the nearby locations. So they can know what the competitors are serving, not individual competitors, but what in general are served in the area, what is trending, what are people drinking a lot of, and they can make ordering decisions based on that. Completely data-driven experience for running a bar and for drinking beer. How cool is that? Okay, I hope I convinced you that this is extremely cool. Now I want to tell you how to build it. One of the more tempting ways to build it is that you already have software as a service. It's not particularly data-driven. You don't have a lot of real-time data. And someone shows up and tells you, our users are asking for reports. Can you give me some reporting capabilities for my users? And if you are a developer and you're kind of early and a startup and you want to move fast, it's very tempting to say, sure, I already have all this data in my production database, my OLTP database. Let me put a report button and run some queries and let customers show all this data that I already have in my database to my customers. In my personal experience, it works more or less for your first 3 to 6 months running software as a service. After that, you discover that your production database was not meant to handle these kind of queries. Not only are the reports a bit too slow, it also hurts the performance of everything else on your website. And remember, performance, responsivity, low latency, this is table stakes. Don't mess this part up. So after a while, your production database is dying, and you have to start thinking, how do I move those workloads that were never supposed to be there? It's an OLTP database. It was not designed for it. It was not tuned for it. It was not built for any of this stuff. How do I move it out, right? This is what happens if the product is at all successful. And then if you happen to listen to data warehouse vendors, they may tell you, oh, you probably already have a data warehouse, or at least you need one. This is for your internal people, right? They need something to look at business data. And it already have all this data, and you already use it for slicing and dicing. Why don't you just run your production system on top of your data warehouse? And people actually say it in straight face. And terrible idea. Production warehouses, again, not built for it, not optimized for it. And to make things a bit worse, they're often controlled by not really production engineering. It's often controlled by an internal business unit whose top priority is not to keep the system up and responsive for everyone, but to create the new pet report for the CEO, CRO, CPO, whatever they need. That's the top priority, right? If the CEO asks for a report, it has to be on their desks in 10 minutes. They don't prioritize the rest of the production system. They usually don't know how to maintain production-grade pipelines. It's just different business capability. So it's extremely risky to try to use the same system for both, for all those reasons. And the way that my co-founder says it is that we really want database to do everything. But databases really cannot, a single database cannot build everything. And it's almost physics, if you think about it. You have to lay the indexes up in some specific way, and they have to be optimized for something. You have to lay the table out in specific ways. The CPU have to be doing one thing or a different thing. You really cannot have all those competing workloads on the same database without basically turning it into two separate databases that happen to be running on the same machine, and even that is just barely. So what you really need is to build a data platform that will provide all kinds of capabilities for your production system at production grade. So I'm going to look into 2 reasonable data platforms that you could build. And the first one is very common from the LinkedIn data architecture talks and conversations. It's something we've seen a lot. It's basically you have data, big data, data warehouse, data lake house, whatever it is that people do massive analytics on one hand. You bring all the data into that, just like you would into a data warehouse. You do a lot of slicing and dicing there. You put the result on a serving tier. And then, on top of the serving tier, you put your application. And I'm showing people you may know, because I think people may know is probably the most important example for that. The calculations over the giant graph are happening at night in the background. And again, it's OK, because worst case scenarios, they will show you the photo of someone that you haven't talked to in 30 milliseconds. Not the end of the world, right? It doesn't have to be real time, and therefore it's OK to build it in that way. Now, you can make it more real-time-ish. So if you, instead of processing the data in a big lakehouse, you also have some kind of a stream processing job, you can get it faster. But it doesn't negate the fact that the data is pre-processed. So you are limited in how much slicing and dicing you can allow people to do, because you are serving it off kind of a limited tier, RocksDB, Cassandra's, these kind of things. So there are limits to what you can do with a single serving tier. There are limits, by the way, but it's a lot. I'm not saying that it's bad. If these are your needs, great architecture, but it's limited. The alternative that gives you more flexibility is really using an analytical database that is designed for real-time analytics in production. And you have to be designed for that. You cannot just pick something else and say, OK, this is good enough. As we've seen, it will not work with your data warehouse, not work with the OLTP, not work with the key value store. You need something that is custom for that. And then your architecture ends up being a bit like this. You end up running your application. Usually, the front end talks to a bunch of microservices, right? You already have this. This is not new. And then you have OLTP data, highly relational in your RDMS, real-time analytics, somewhat relational, optimized more for those big slice and dices in real time for very fresh data in the analytics store. And you use streaming with very minimal processing, because you want the stream to be extremely fast, not to do tons of aggregates. Streams with minimal processing, moving data in between. The key to making it work, and I'm going back to the theme of trust, is that you need a secure access layer that basically unifies the OLTP and the analytics side. Because just imagine that someone does not have the permissions to see a specific repository in GitHub, but when you look at the analytics page, here you are, now you can see all those things, even though when you looked in a different way, you did not have permissions. You must apply your role-based access controls, or whatever your favorite form of access control is, uniformly across your entire data platform. This is what makes it a platform, and not just, oh, I'm running 2 databases in production. So pay attention to that. The APIs and the queries should ideally also be unified. The people writing UI, they should not have to think, is my data coming from relational database or analytics? They should just basically send queries and send API calls to this platform and have the platform handle it for them. This is not to say that you're getting rid of your data warehouse. The internal people that we just told them that they don't need real time, they will be extremely happy with the data warehouse that is, our old data, and they can slice and dice and do not interfere with production. So keep this one, but it will not be your production architecture. This is your production architecture. OK, that was a lot. Let me recap for you. First of all, I encourage you to build real-time architectures for your customers who actually need it and willing to pay for it, and not for internal people who don't need it and are not willing even to pay for it with their spare time. Second thing, if you are aspiring to build modern SaaS, if you want to have a competitive SaaS service, it has to be collaborative, it has to be data-rich. This is what people these days expect. And the third one is that you cannot deliver this experience, you cannot deliver this amazing SaaS that your users will love and trust without having a production-grade data platform behind it, one that is low latency, flexible, and secure. So keep those in mind, and I think you have just 10x'd your chances of success. Thank you so much for attending my talk and spending this morning with me.